Welcome to video 8.1. Today we're going to talk about simplifying radicals. So the first question is, how can you determine if a number is a perfect square or not? And we talked about this before. So our perfect squares are numbers when we square them. So we can determine if it's a perfect square or not by taking the square root of it. The answer should be a rational number. If the answer cannot be written as a fraction of integers, it is then irrational and therefore not a perfect square. Here's our procedure to simplify radicals, which are non-perfect squares. If it's a perfect square, we can just take the square root of it, and then that is the simplified version. But when they're not perfect, we have to simplify the radicals. So the first thing that we need is the list of perfect squares. I say from 1 to 225, listing those out because those are normally the range will be between that. If we needed to go higher, we could. So we write this list of very important perfect squares, the VIPs list over here. So the VIPs are very important perfect squares. So I can list those out. You can also find them in your calculator by hitting y equals and then putting in x squared. When you look at the table, you'll then see the first one is the 1 times 1, 1 squared, which is the first very important perfect square, and then so on and so forth down the list. So there we have all those very important perfect squares listed off to the side. The next thing that we do is determine where the number under the radical, that the number that we were trying to simplify, would fall in the list. So say the number is, I don't know, 94. We would say, okay, well, 94 falls between 100 and 81, so it would be right there. And then you start working your way back through the list to see which one of these perfect squares go into the number we're trying to simplify. The reason for this is that'll tell us the biggest number that goes in if we start at where the number actually falls on the list. Then work up the list, determine the largest perfect square that divides into your number without having any remainder. Then under a new radical, we'll replace the old number with the factors. The first one needs to be the perfect square from step 3. And then we take the square root of the perfect square, crossing it out, and bring the result in front of the radical, leaving the non-perfect square under the radical. If there was a number out in front of the radical, we would just multiply it by the new number that we're bringing out front to get our final answer. Okay, let's look at a few examples. The first one here is the square root of 18. If I look on my list, I can see that 18 would fall between 16 and 25. Then I start working backwards through the list to find something that divides in. 18 divided by 16 doesn't work. Divided by 9, 18 divided by 9 does work. So that's our first perfect square that goes into the number. So I'm going to rewrite a radical and put 9 times 2, since 18 divided by 9 is 2, under a radical. So then I just rewrote my radical. Now I can take the square root of 9, so that can get crossed out. That means I'll put a 3 out in front of the radical. And the reason for that is because the square root of 9 is 3. And then under the radical, I can't take the square root of 2, so that has to stay under the radical. So that's my answer for the first one. Let's look at another one. This one is a little different just because there is a number out in front of the radical, so that means when we do move a number out, we'll have to multiply them. So we have the -4 just coming along for the ride. Then I look at 98. Where does 98 fall in the list? Or really, you could do half of the number since we know nothing bigger than that would go in. But we'll start at 98. It falls between 81 and 100, but 81 is not divisible. 98 is not divisible by 81, then keep going backwards. So try dividing by 64, that doesn't work. 49 does work. It comes out nice. We get the answer of 2. So now under the radical, I'm going to put the 49 and the 2. So now I have the radical 49 times 2. I can take the square root of 49. That was the whole point of simplifying this. So the square root of 49 is 7, so I'm going to put that out front with the -4. The 2 is still under the radical. Then I can do -4 times 7 to get the -28, and then a radical 2 still stays because that's irrational, so I have to leave it as a radical 2. Okay, that's it for today. We'll do more examples tomorrow. Have a good night. See you tomorrow.